Now let us evaluate this line integral y plus x dx plus y minus x dy over c, where c here is a square with successive vertices 0, 0, 1, 0, 1, 1 and 0, 1. That means these are the 4 vertices of that square. So first of all, what you need to do is plot this point, the vertices of this square in the xy plane. So you draw the xy axis, and then 0, 0 is the origin only. You mark as O, and then 1, 0 is a point which lies on the x-axis. Mark a point 1 here, then denote this one as A, 1, 0. Then B, take a point B which has 1 on the x-axis and 1 on the y-axis. So it will be a point here, because by taking 1 here on the y-axis, so this will be B, 1, 1. And 0, 1. 0, 1 is a point on the y-axis which has a 0 x coordinate, where the x coordinate is 0 and the y coordinate is 1. So this will be the square. So now, where C is a square with successive vertices, so here we have to evaluate this one, y plus x dx plus y minus x dy over C. So let us take this line segment C1, which is along this line, C2 this one, C3 this one, from B to C, and from C to O, the origin will denote it as C4. Therefore, the integral y plus x dx plus y minus x dy over C can be split into 4 integrals. One is y plus x dx plus y minus x dy over C1, that is along this line segment, plus integral y plus x dx plus y minus x dy over C2, plus next one is y plus x dx plus y minus x dy over C3, and the last one is integral over C3, that means along this line segment from B to C, and the last one is from this one from C to O, which is a line represented by the line segment C4. So it will be y plus x dx plus y minus x dy over C4. So now let us see here along the line C1. You can see that along the line C1, the x coordinate is 0 and here it is 1, but the y coordinate remain as 0. So now in C1, you can write in C1, y is fixed as 0. So this implies that dy will become 0, and x varies from where to where? X varies from, it is from 0 to 1. So x varies from 0 to 1. Now in C2, that is along this line segment, you can see which one coordinate is fixed. Here you see that the x coordinate is 1 here, here also it is 1. So that means x coordinate is fixed as 1, but y coordinate varies from 0 to 1. So in C2, x is fixed as 1, and if you differentiate this one, then you'll get dx is equal to 0. And y varies from 0 to y is equal to 1. Now let us check along the line segment C3, that is from B to C. Which coordinate is fixed here? The x coordinate is 1 here, but this one x here coordinate is 0 here, but 1 is fixed as 1. So that means along C3, the value of y is fixed as 1. So in C3, y is fixed as 1, and this implies that dy is equal to 0, and x varies from 1 to 0. And the last one is along C4. Along C4, you can see that in C4, x is equal to, let us see, in C4 you can see that the x coordinate is 0 here, and the origin also it is 0. So the x coordinate is fixed as 0. So this implies that dx is equal to 0. And this will implies that, okay, dx is equal to 0, but what about y coordinate? Y is equal to 1 here and 0 here. So that means y varies from 1 to 0. So therefore, the line integral y plus x dx plus y minus x dy over C becomes what now? Over C1. Now in C1, y is fixed, y is equal to 0. So you replace the value of y is equal to 0, and then dy also by 0. So along C1, x varies from 0 to 1. So it will be from 0 to 1. Then it will be 0 plus x dx plus 0 minus x into 0 because dy is 0 plus along C2. Along C2 x is equal to 1 and dx is equal to 0. So it will become y is fixed, y will remain as y only plus now x has to be replaced by 1, but what is dx? Dx is equal to 0 plus y minus now x here will become 1 into dy and y varies from where to where? It is from 0 to 1. Now we'll just take that one plus the line integral along C3. Along C3 y is fixed as 1, so which means dy is equal to 0 and x varies from 0 to 1. So it will be 1 to 0. Then here y is equal to 1, so it will be 1 plus x dx plus y minus x, that is 1 minus x dy, but dy is equal to 0 plus the last one, that is along C4. Along C4 x is fixed as 0 and dx is 0, so it will become y plus 0 into 0 plus y minus 0 into dy, and here y varies from 1 to 0. So finally the value of the integral is, now here you see that it reduces to just x dx, and integral of x dx will be x squared by 2. So it will become x squared by 2 from 0 to 1. And from the second one you can see that this part will vanish, then y minus 1 divide, and it will become y squared by 2 minus y. So it will be y squared by 2 minus y from 0 to 1, and then plus now the third integral, this one, this part will be 0 and here it will become x plus x square by 2 from 1 to 0 plus the last one is, this part is 0 and here it becomes y dy, so it will be y square by 2 from 1 to 0. So you can substitute the limit of integration here, and then you'll get the value of that integral over the curve C represented by the square whose vertices are 0, 0, 1, 0, 1, 1 and 0, 1. Hope now it is clear how to evaluate this line integral.